All right, create an explicit rule for the geometric sequence right here, then find the fifth term. Okay, then graph the explicit rule here. So the first thing might be easiest actually is to graph. So let's simply graph these values. We know our ends are down here, so just put 1, 2, 3. Let's go ahead and do that. And then we're going to put these numbers on our y-axis. It's called an Fn. Now, the biggest number there is 120. So I need to get 120. So I got to go and fit 120. 120. I also have a 60 and a 30. Maybe. With 30s work? Does 30s look like it will work? 30s would work. 20s might work. I like 30s because 30s fit this, but let's do 30s because it looks like it will fit. So I'm going to do 30, 60, 90, 120. Does that fit them all? All right. So what I'm going to do now is I'm going to put, at 1, I'm going to put 120. So at 1, I'm going to put 120. All righty. For 2, we're going to go to 60. So at 2, we're going to be at 60. And at 3, we're going to be at 30. Now, these do not form a line. It's a curve. Do you see kind of more of a curve going on here? Later on, we're going to get the fifth term. I'm going to plot it. I'm going to plot the fifth term. Later on, it'll be right here. And we'll see if it follows a curve. After we find it, we'll plot it just to see what it looks like. But we just made the graph. Plotted the 3 dots we know. Okay, I need to now make the rule and then find the fifth term. Now, could you find the fifth term just by keeping the pattern going? Yeah, you could just look at the pattern, keep it going, and get to the fifth term. But what we're going to do is find the rule and use the rule to find it. So to get the rule, here's what is the major function we're going to be calling. To get the rule, it's Fn is the rule, meaning we have nth term. The rule is going to be F0 times r to the nth power. Now, you might wonder, what is all this? Well, F0 is the term in front of the pattern. R is called the common ratio, which we'll talk about in a second. And n is just the variable you'll be changing. It's the n, this number you're plugging in as you go through them. So our goal now to use this formula is we need to, I'm going to box that. That formula is really important. But to do that formula right here, we need F0 and R. Now to find R, you're just trying to find what's happening, the pattern. So if you look at this, some of you can just see that. What's happening? Well, can you see you're not doubling, you're shrinking, aren't you? So do you see that you're halving each time? Or you're dividing by 2? And do you see how you're repeatedly dividing by 2? So we know we're dividing by 2. That is called your common ratio. Now, if you can't just look and see the pattern, how it's shrinking, okay, then you have to have a formula. And the formula to find your common ratio is simply going to be take the second term divided by the first term. Can you take the second term divided by the first term? So for this situation, it's going to be the second term is 60 divided by 120, which when we reduce that is 1/2. So my common ratio is 1/2, which isn't 1/2 mean divide by 2? 1/2 means to divide by 2. So we are dividing by 2 repeatedly. So all we did to get common ratio is second term divided by the first. If this was arithmetic, we would be subtracting or adding. This one is geometric. Geometric, you multiply or divide. Arithmetic, I might have said that wrong, is adding, subtracting. Geometric is multiplying, dividing. And since we're shrinking, can you tell it's dividing? If this was growing, wouldn't you be multiplying as you go along? So you're just trying to understand how is your pattern changing. And you're changing by halving or dividing by 2. It's the same thing. Now, the question is, we have R. Okay, so we have Fn is equal to, we have R is 1/2 N. Okay, so how do we get this number? How do we get F0? Well, F0 is the number in front of the pattern. So if we have 120, what's the number before the pattern even started? Well, if we're halving this way, to get from 30 to 60, didn't you multiply by 2? To get from 60 to 120, didn't you multiply by 2? So how do you get in front of this? Well, to get F0, which is the term in front of it, aren't we going to take 120 and multiply by 2? Do the opposite. Again, if we're trying to get in front, we are multiplying by 2. As you try to go the opposite direction, you're doing the opposite operation. So what do we get when we take 120 times 2? We get 240. So won't this number right here be 240? And that is your equation. Because the term in front of this pattern is 240, and what's happening through the pattern, how it's changing, is you're halving as you go down. Now, why do I care about this rule? It's called the explicit rule, by the way. It's just a name for it. There's also something called a recursive. We're not going there right here. But for this explicit rule, what's useful about this is I can now find the fifth term. So to get the fifth term again, we are going to put 5 right there. So the fifth term is f of 5 is 240 times 1/2 5 times. Basically what we're doing is saying 240 and halving it 5 times. Now that's kind of annoying, but you could use your calculator to do that. And what you're going to end up with is, this is going to be 240 times 1 over 32. Now I might have lost you there. Where did I get 1 over 32? If I took 1/2 to the 5th, it's 1 over 32. Don't worry about it. If you put it in your calculator, you pop an answer out. So this would end up being either 15 over 2, which is 7.5. Doesn't matter which one. No. You can put your answer as either of those. Whatever makes you happy. They're both equivalent. So this right here is the fifth term. This right here is the rule. This right here is the graph. Did we answer everything? Is that everything they asked for? Yeah. Now I just want to plot 7.5. Isn't 7.5 easier to plot than 15 over 2? So at 5, wouldn't we be way down here? Do you see the curve? Do you see how it's going and getting curving and curving and flattening out? Do we have to put this dot on the test? No. I just want to see it to help me see the curve better. I just wanted to put it on, just for the sake of seeing what's going on. So, right, this is the formula to get the rule. Here's the rule. Here's the fifth term. Here's the graph. Now, be careful on this test. If your values are shrinking, shouldn't your R always be a fraction? Because if I'm dividing, say, by 5, isn't that taking a fifth? But if your values are growing, shouldn't your R be not a fraction, but a whole number, a big number, bigger than 1? So just be aware of that. That's important to check your work.